On December 19, 2013, in a paper published in the research journal Cell, by administering a molecule naturally produced by the human body, scientists, led by Dr. David Sinclair, were able to reverse the metabolism in the human equivalent of a 60-year-old mouse to that of a 20-year-old mouse in 1 week. Tissue samples showed key biological hallmarks that were comparable to those of much younger animals. What has changed, in your view, in terms of how we can intervene in the aging process at this point?
Yeah. Well, I think that there's been a very large shift in how we think about aging, and it's one-way direction. When I started in this field, seriously about 20 years ago, the idea about aging was that we lose our telomeres, the ends of our chromosomes, we get mutations in our genome, and these are things that are largely irreversible. And if you try to reverse them, for example, with telomeres, you worry about getting cancer. So the idea back in those days was this is a one-way direction. The most we could do is to slow it down slightly, and that was our goal. But more and more, what we're seeing in the lab and at conferences I go to is that we should be able to reverse aspects of aging. Here in my lab here at Harvard, we've got some early evidence that we can very rapidly turn back the metabolic clock, at least in mice. And this happens within days. And we're just starting, but I think eventually we'll learn more and more of the process of aging will not just be slowable, but reversible as well. When you say the metabolic clock, what are you talking about specifically? Well, as we get older, it's very clear, and we scientists agree on this, that our metabolic rate goes down, and there's a particular molecule that we study that we think is critical for life, NAD it's called, and its levels go down from a high of, let's say, 100% when you're young, down about 50 to 50% when you're older, in your 70s and 80s. And this is a critical molecule for life. And what we're finding is that when we boost the levels back up to young levels again from in an old animal, that they're rejuvenated, and their metabolism, the way they process energy, the way that they use their mitochondria are these battery packs of the cells, they revert back to a youthful state, and the animal has protection from diabetes, among other diseases, because of this reversal. When you reverse one thing, would the organism be mismatched, meaning some things get younger, some things are not getting younger? Does everything have to move together? Well, ideally we want everything to move together, but there are some parts of the body that seem to be harder to reverse, or at least in theory will be harder to reverse. For instance, buildup of plaque in the brain for Alzheimer's I think is going to be extremely difficult to reverse, if at all possible. But other things, like the metabolic shifts, these things seem to be quite malleable, and we can reverse those quickly. And it's a good point whether we need to reverse everything at the same time, or if it's okay to fix one organ at a time or one system at a time. I think the latter is the way we should go, and that we should try to fix one system and another, and that eventually we'll end up being healthier. But I'm not worried about things being mismatched. Even as we age, we end up being mismatched, so we're just trying to bring them back a few at a time. You guys would like to inform the public and have them understand this, and yet you're working in a mouse which ages 20 or 30 times faster than a human. How do you prove it? Well, ideally you want to prove it in people with a clinical trial, very standard methodology that companies and others use to make drugs. And that's what I've been doing. I've been working through a drug development program so that we can actually prove to everybody, including the FDA here in the US, that we are actually preventing diseases that aging causes. For instance, diabetes, heart disease, Alzheimer's. Among others, there are hundreds of diseases that you could lump into the aging process. And so eventually what I think we'll be able to do is to show with firm confidence, scientifically, that we are actually slowing down aging itself. The reaction of the average person is that if you extend lifespan, they're just going to be old, connected to tubes. What are you guys trying to do to break through that? Well, I think we need to change our view of what's old. The problem with quote-unquote anti-aging work is that the immediate thought of people is that we're just going to prolong old age. And I don't think anybody wants that. I certainly don't. What we need to convey is that we're prolonging health and youthfulness so that an 80-year-old can still, most 80-year-olds could still play tennis and hang out with their great-grandkids with no pain, no suffering, no chronic diseases that plague many people even before their 80s. And it's that disconnect that we're not keeping people in nursing homes for longer, we're keeping people out of nursing homes. And that's often a message that's missed when people don't look deeply into this research.
You're serious scientists, but you're tackling the fountain of youth. And it was a myth. The idea that myth could become reality.
Well, it's true that we scientists who are working on the molecular biology of aging at the cutting edge of science, we do get lumped in with thousands of people who have come before us who have promised things that have not come true. There are snake oil salespeople who have come before us and exist now that tend to muddy the waters and make it a challenge for us to be taken seriously. Even among other scientists, it's been a struggle actually to be taken completely seriously. It's getting better. Our field is definitely recognized as one of the most cutting edge and potentially important for medicine. But yeah, there's still skepticism, both among scientists and the general public, because what we're doing has never been done before. I think when people first said, let's go to the moon in the 1920s, they were probably laughed at because the idea that this could be done was just so far beyond anything that they were used to seeing or hearing. And that's where we are. But it's changing as we make breakthroughs scientifically and get closer to that reality. I think other scientists and the general public are starting to realize, you know what, this might actually be real. It's going to happen. When it'll be able to be applied to humans, that's the big question.
Do you feel evolution itself evolves?
I think that Darwin had it right, and that we evolve the same way we have been for the last 2 billion years. But that's not to say that we humans cannot change evolution. And this is controversial, but I believe we have the power to determine our own evolution, and that we're not just at the whim of random selection, natural selection and random mutation. What that means is that we should be able to determine where our species goes biologically. We should be able to determine how we're helped by machines that we build, and eventually we'll be far beyond anything that evolution could have by itself created.
The common refrain is that history repeats itself. In the words of George Bernard Shaw, if you have read Back to Methuselah, you will remember Franklin Barnabas, the ex-clergyman, who with his brother Conrad, the biologist, had come to the conclusion that the duration of human life must be extended to 300 years. Not because people would profit by a longer experience, but because it was not worth their time to make any serious attempt to better the world or their own condition when they only had 30 or 40 years before they doddered away into decay and death. The brothers Barnabas were in fact the first discoverers that it is our expectation of life and not our experience of it that determines our conduct and character. Consequently, the very vulgar proposition that you cannot change human nature is valid only on the assumption that you cannot change the duration of human life. If you can change that, then you can change political conduct. It was on this thesis of the Barnabases that I was concerned when I wrote Back to Methuselah. The words of George Bernard Shaw. If you thought you were going to live to 150, all of a sudden global warming's important? So would you address that idea?
Yeah, if people did live 150 years, they really would think differently about the future. I can actually see this in college students. They're worried about the future, generally worried about the environment and what's going to happen with politics. As we get older, I find this with myself. I'm more worried about the day-to-day, and I think that it would change if we really did know that we were going to live another 100 years. I certainly would change the way I view it. It helps to have children. We want the best for them. But I think we're all generally selfish people, and we focus on our lives and what will be involved as we're alive. And I think that that would change dramatically if we could live longer. And that would be one of the great side effects of being able to live longer, not just allow people to live healthier lives, but the whole view of politics and the way politicians behave would also change.
It's not clear how the politics of these advances will develop. In a 2004 NPR program, David Sinclair debated with the chairman of the Bush administration's Council on Bioethics, Leon Kass, who had written, "The finitude of life is a blessing for every human individual. If our children are truly to flower, we must wither and give ground." Sinclair's response was that in his view, this research will lead to longer and healthier lives. Should we have stopped treating people with antibiotics when those drugs began boosting life expectancy?
It would be a fantastic thing if we could live longer and healthier. And we'll have to adjust. I think it's true that there will be economic impact. Social Security will have to be revised in the way we do this. But we make changes, and we've made changes over the last 100 years, and we're not going back. I don't think anybody wants to.